This is the solution for constant surface temperature with an average heat transfer coefficient. Let's consider a period of tube with a length of x, and consider heating case first, which means we will have our tube surface temperature larger than the mean temperature of the fluid. At the inlet of the tube, we say we have the mean temperature Tm in, and at the outlet, we have mean temperature TMO. And let's consider a finite length of tube, which means at the outlet, the temperature is still smaller than what we have for the tube. On Wednesday, on the delta TO here is the outlet temperature difference between the surface tube temperature and the main temperature at the outlet. At the inlet, similarly, inlet temperature difference, delta T in, is what we have between tube temperature and the inlet temperature. This is a constant here, but this guy, the outlet temperature difference, according to what we have here, the solution decays exponentially along the length of the tube. Now, in order to calculate our convective heat flux from the tube surface, the temperature difference is always varies along the length. We need to use some average value. We use the average convection heat transfer coefficient, and then we define this guy, the delta TLM. This is what we call the log mean temperature difference. And it is defined as delta TLM is what we have for outlet temperature difference minus what we have the temperature difference at the inlet over the lowering of the ratio between outlet temperature difference and the inlet temperature difference. The way we define this, why should we define this log mean temperature difference? Because from that theoretical solution, it's the temperature delta T obeys exponential decay. So in this, and for the outlet temperature and inlet temperature, it is always easy to measure. So based on this, we can calculate, so use this log mean temperature difference as our average temperature difference. When we learn heat exchanger 2 weeks later, we will have a parallel heat flow heat exchanger. Hotter fluid and colder fluid moves at the same direction. Of course, they exchange heat. Hotter fluid get colder fluid get hotter, and the temperature difference between them decrease. We will also apply this log mean temperature difference to serve as the average temperature difference to calculate our heat exchange rate by convection. Surface area exposed to convection times the convective heat flux, and we know it can be approximated by the average heat transfer coefficient and the delta T log mean temperature difference. That's the way we calculate heat exchange by convection for a finite length of tube for internal flows.